Hello everyone, we're going to do section 2-2 today, conditional statements. Our objective for today is to identify, write, and analyze the truth value of conditional statements. And also we're going to write the inverse, converse, and contrapositive of a conditional statement. So for these first three, you can just say, see next page. I started writing them on there, you can see my whiteout, but I decided we're going to go over them again on the next page, so there's no reason for you to write them twice. The truth value of a statement is whether the statement is true or false. Pretty obvious, right? The word truth value should tell you if a statement is true or false. Negation sounds like what it is, making a statement negative. And these last four, we're going to work with them on the next page as well. So go ahead and catch up and pause it and then catch up and then turn your paper over. We are on conditional statement. So here we have conditional statements. There we go. And our symbols are, so a conditional statement would be, for example, if anything, and usually we say the lower letter P, then Q. Now this P and Q can be anything. It could be if it is Saturday, then tomorrow is Sunday. It could be if it is raining, then there are clouds in the sky. It could be if an insect is a butterfly, then it has 4 wings. It could be anything. P, then Q. So P is anything and then anything else. So in symbolic form, what that looks like is P arrow Q. The arrow means then. So if P, then Q. And if I was to draw a Venn diagram about this, I would have a Venn diagram that looked like this, where I would have P here and I would have Q out here. So if P happens, then Q is always going to happen. The hypothesis is the P part, the P part. And it's usually followed by the word if after the if. So if P, so that's my hypothesis. The conclusion is the Q part. And it's usually after the then. Okay? So that's my conditional statement. Now, we can take our conditional statement and we can mix it around a little bit and we can get a converse, an inverse, and a contrapositive. So our conditional statement is written in the form if P, then Q. And we already learned that the symbol is P arrow Q. So my converse is when I take the P and the Q and I flip it around. So that would be if Q, then P. So in my symbols, that would be Q arrow P. My inverse starts putting in some negatives, and we talked a little bit about what a negation is, making a statement negative. So my inverse talks about making something negative, and what I do is I take my original conditional statement and I make it negative, and so that would be if not P, then not Q. And you know what? I realized I should be putting commas in here. So make sure to add a comma up there as well. So if not P, then not Q. So how that looks in symbols is we have a little squiggle. It's a tilde or an ñe if you learn Spanish above an N. So you have a little symbol there that means not. So that means not Q. And then we have an arrow, not P. Okay, and then the contrapositive is when I take the converse and make it negative. So that one says if not Q, then not P. So again, you can probably figure out the symbols for this. So that's not P, arrow, not Q. Okay? Now, I also wanted to point out to you on the back side here, or the front side here, you saw logically equivalent statements. I'm also going to go over that with you. So logically equivalent statements are statements that are different forms of the conditional, but they are both true or they are both false. And they are equivalent in their truth value, is what that means. So the logically equivalent statements here are the conditional and the contrapositive are connected, okay? And the converse and the inverse are connected. So that means if the conditional is true, then you know without a doubt that the contrapositive is also going to be true. If the converse is true, then you know without a doubt that the inverse is going to be true. Okay, so for example, let's do an example, and we have some room on the front side of this paper, so go ahead and turn this back to the front, and I'm going to do an example with you, okay? Let's see. If measure of angle A equals 95 degrees, then angle A is obtuse. That's my conditional statement. That's if P, here's my P, then Q. So this is my hypothesis, and this is my conclusion. Okay? And that is my conditional statements. That's my P arrow Q statement. That statement is true, right? If it's 95 degrees, then it is obtuse. That is a true statement. So the truth value of this statement is true. Now let's look at the converse. And remember, that's Q arrow P. So that's going to be if angle A is obtuse, then measure of angle A equals 95 degrees. You'll see what I did is I just flip-flopped these two here. I just flip-flopped them. That is false. Why is it false? Well, if it's obtuse, does it always have to be exactly 95 degrees? No. Let's think of a counterexample. A counterexample is any example that makes this statement false. So in this case, my counterexample could be that the measure of angle A could be 100 degrees, or 110, or 179. Notice measure of angle A is 100, and it's still obtuse. That's my counterexample, okay? So now let's do the inverse, and that one is not P arrow, not Q. So that's going to take this first one, it's going to say if the measure of angle A is not 95 degrees, so notice I put a not symbol there, then angle A is not obtuse. And the contrapositive is not Q arrow, not P. So that's going to say if angle A is not obtuse, then measure of angle A does not equal 95 degrees. So some students have really difficulty trying to decide the truth value of inverse and contrapositive. And remember I told you that the conditional statement and the contrapositive statement are shared truth values, and so they're equivalent, and converse and inverse are also equivalent statements. So that means that if this first one was true, then I know without a doubt, there's a different color here, that the last one is also going to be true, because those two are logically equivalent. If I know that this second one here is false, then I know that the third one is also false, because they are logically equivalent. I don't have to navigate the nots and the not equal to. Sometimes it's hard to think in terms of negation. It's easier to think in terms of the regular converse and the regular conditional. So as soon as you get these two done, then you know what the pattern's going to be for the rest. If both of these are true, which could happen, then that means all of them would be true. Okay? Okay, this last bit here, go ahead, and we did a good video today, so you can go ahead and cross that out today. Don't need to write that down, and we'll go over more of this in class time. Okay, thank you for watching.